So I'm going to talk a little bit about what we've done at Concur with Selenium, and we have a somewhat of an interesting story to a lot of people here, because prior to using Selenium, we're a QTP shop. So we'll talk a little bit about what that experience has been like and what we've kind of taken from the QTP world and applied with our Selenium deployment. So before I get too far, just a brief introduction to Concur. If you don't know who Concur is, I'm kind of required to put the slide up here. Then I'll go through what our goals for automation are, some of our facts and figures, kind of gauge the scope of our deployment so you have some idea of how it compares to what you might be trying to do. A little bit of information about our application under test, and some of the challenges we face. Then we'll talk about some of the core components of our framework. Okay. So who is Concur? We're the world's leading provider of on-demand employee spend management. Hopefully some of you will be using Concur solutions when you go back to your office to file your expense report. Also, hopefully some of you use Concur solutions to book your trip to come here. So that's essentially what we do. We have about over 10,000 clients in 90 countries, about 15 million users. Just some idea of transactions. We do about 8 to 10 expense reports per second during business days. We process about 55 million transactions per year, and it's about 50 billion in total travel and expense spend. So that's a little bit about us. We're one of the Fortune 100 best small companies. We were number 37 this past year, so we moved up. And some of you may know us in the San Francisco area from our recent acquisition of TripIt, which was a very awesome application for mobile devices for tracking your travel. So if you haven't checked that out, you should do that, because it's quite cool. Okay, so I've been working with automation for a long time at Concur, and when I started at Concur on the automation project, we had zero in the way of automated test cases. So our solution was from scratch. What we had, though, was an idea of what we wanted to do, and so we took some principles that we put together. We want to basically provide comprehensive coverage for our application. That's what our stated goal is, and we want it to be obviously reliable and accurate. If automation gets positive results, then we must be able to count on it to do for the evaluation of the application without further need for manual verification. And you'll understand why that's so important to us as we go along, and I think that maybe goes without saying. You want it to be accurate. We want it to be maintainable, because our applications are quite, they're in a significant amount of flux as we go forward each month for the releases. There's a lot of change, so we need to be able to have our automation keep up with that. So maintainability is very important to us. We also need to expand it. We need to be able to continuously expand it, because right now we service about 14 different services from the Concur application stack with automation. Our best coverage from a function point coverage standpoint is 55%. Our worst coverage is 2% of these services. So obviously we want to continue to drive the coverage up. We have lots of work to do. There's no shortage of activities for us to take on. So that's why we need to be expandable. And we seek to marry the functional knowledge with the technical knowledge. And so this is a very important point for us, is that in our initial deployment of automation, we were using QTP. And as some of you who have used QTP know, it's more of a development tool. So your engineers who are writing QTP, or if you're writing QTP, you're more likely to be more technically inclined and less focused on the functionality of the application. And so what we're trying to do with Selenium, or what we did try to do, and we've accomplished it to a fair extent, and we're going to continue to go down this, but we want to marry our functional knowledge with within our test team to the automation that we're building, so that we have automation engineers who understand the detailed functionality of the system. So when they see a behavior in the system, they know if it's right or if it's wrong, or if it's something that nobody is quite sure what it's doing yet. So that's something that we were looking to do with Selenium is really get to a point when we moved off of QTP. So we would have a test team of engineers who were writing code for automation, but they were also more functionally aware. Okay, so a little bit about our goals, and this first one is quite important to put out there, and you'll understand as I go through a little bit more about the details of what we're doing as to why I specifically state this. But we're interested in application coverage. We're not necessarily, or I'm not necessarily, interested in the latest and greatest technology. What I want from a technology stack for automation is something that works, that's reliable, that's expandable, but it doesn't have to be the latest and greatest. It doesn't have to have the latest bent. And so when we look at using our Selenium deployment, where we have nearly a million scripts executing per month, it's written mostly in the HTML format or Selenium ease. So this is quite surprising to a lot of people when they learn this, because they would say, why didn't you move to Java or something more of a programming language? And my response back was, well, we will when we reach a point where we can't accomplish what we need to do with the HTML code. Because the HTML code is faster to create, easier to maintain, and from a standpoint of how many people we can get to a point where they can be productive at creating automation scripts, it's much easier. Okay? So that's important, but it's also, remember, we want our automation to be expandable, to be scalable. So technology is important. It's just not the driver. Okay? We strive to have 80% of our automation efforts focused on building coverage and 20% on building framework. So how do we define the differentiation between, well, if we're writing a test that's actually testing the application, that's coverage. If we're writing code to support the application, the automation applications, then that's framework. So of our team of engineers, we're divided in such that we have essentially that type of breakdown. That's what we're striving for. We also have a rule of thumb, and this is quite important that I continuously repeat to our development teams. We only want to automate something that can be executed 8 to 10 times before we have to change it. And so why is that important? Because the cost of executing, or cost of creating an automated script is more expensive than doing manual executions. We think our break-even point is around 8 to 10. So if we have to change the automation script before we've executed it 8 times, then we didn't get our payback. Okay, so it's something to note, and this is particularly important as new features come out, and for us in an agile development process, our new features come out and they look like X, and tomorrow they look like Y, and the next day they look like Z. So if you try to follow that with automation right when they're coming out, you're going to spend a lot of time redoing your code without actually running it much. Okay? So as I mentioned, we did convert to QTP. About four years ago is when we started the process, and I will say this, it's quite exciting. 5 years ago, I was at a QTP conference that I think was of similar size, maybe a little bit larger, but certainly similar size in attendance, so it's pretty exciting. Some metrics to go back, and I know obviously there's a lot of decision points, a lot of maybe hesitation on some people's part to go with an open source tool for this type of investment. But when we look at that we can develop scripts 3 times faster in Selenium than we could in QTP, that's pretty compelling. When we look at the licensing cost between Selenium and QTP, that's pretty compelling. And I'm here to tell you, after 3 years of use, we've not run into anything that we couldn't figure out how to accomplish with Selenium any more so than we could with QTP. Because we always had a list of things that we couldn't accomplish with QTP. So we have a list with Selenium as well. The list is actually quite a bit shorter. And I like to throw this out when I talk about the comparison. I still have an open support case with QTP that is going on 5 years now, that they haven't solved the problem. And I check in once in a while just to see if they have a solution. I don't really care if they do or not, because it's not relevant to us anymore, but I'm just interested to see how their support is going along. But so when we talk about support, I'm not sure that the support is any better or any worse with Selenium than it was with QTP. So just Since we have started this project, we've had over 40 engineers who are actively or have actively been committers of the Selenium code. And this is somewhat inflated because in the middle of this, we actually moved our engineering center from one location to another, and we started with a fresh group of engineers. And this was a business decision. It had nothing to do with the work that was being done. It was more of a business decision to go from an outsourced situation to our own internal engineers. And so what's interesting through that process is we brought in people 2 years ago. I had 0 experience on my automation team. Okay? And so we had to get them up to speed very quickly on how to use the tool, and we were quite capable. It's gone quite well from a standpoint of how quickly they've come up to speed and become very, very efficient and very innovative using Selenium. So currently we have 12 engineers who are heavily committing to our Selenium source tree, and there are about 5 to 7 others who commit once in a while. We have some feature testers that are actually writing scripts that it's not their full-time job, but they actually do write scripts. Our active inventory, we have 10,000 unique test cases, 14 different services, I mentioned that already. When we execute one complete passive automation, it's equivalent of 133 person weeks. So we do this, 10,000 executions. We run our complete inventory multiple times in a week, and there's numerous reasons why we do that. But when you track that back to how we could accomplish that with manual testing, obviously you can't, not with any reasonable cost structure. Okay? Overall, we've had about 16 to 18,000 unique scripts that we've developed. Some of those have been retired because of product changes. We did, in one of our services, go through a complete UI change, which our scripts are maintainable, but when you change the workflow of the UI significantly, well, you can't really just easily maintain those. So we retired scripts and rewrote those scripts from scratch. Okay. This is what our application looks like. Okay? I can't leave it up here too long. It's company confidential according to the graphic. But essentially, we have several different front-end servers, different types of different flavors, several different services that are all melded together under one common portal, and a lot of back-end infrastructure. And so when somebody asks me why we don't do more continuous integration, this is the reason. Because when you change something on that side, it breaks something over on this side, and the developer over there doesn't even know what this application is. Okay, so continuous integration, we would love to do it because it would make our numbers go even higher. And we have the technology to do that, but we don't have the architecture to support it. So it's very difficult for that. We've made several attempts at it. Okay, some challenges. I mentioned, I kind of hinted to this. We have development teams that are really focused on their specific service. So our organization is divided into about 8 different development teams spread out throughout the country, throughout the world. And they focus on their specific part of the service. And most of them know very little about other parts of the service. Okay, so that's a challenge that we have because QA takes the responsibility to make sure that we have integration working between, because this is really what's important to our overall application. So overall, the next point, kind of going back to the previous slide of why we have so many different pieces of architecture, our company's grown through acquisition. And we bring products in and we don't throw the products away, we integrate the products. And so our technology stack is quite diverse. If you can think of a technology that might be in use somewhere, there's a good chance that we have it somewhere in our stack. Okay? And the next thing, the last point, is something why we have 10,000 test cases, but we run them multiple times, and we need to run them multiple times, is because our deployment is run in multiple phases. So think about this from a test standpoint, where I have one part of the application that gets upgraded, and the rest of the application is still not upgraded, but the functionality still has to work. Okay? And then I upgrade another part of the application, and I still need a seamless experience from the user standpoint. So we actually have 4 different states of deployment. So that means that when we test a feature, not only do you have to multiply it by the number of browsers that we want to support, by the number of operating systems that we're trying to do, by the number of configurations that our customers have. We're already to a matrix that doesn't fit in this room, but then you add in this deployment state and say, well, you need to test this feature so that it works in stage 1, stage 2, stage 3, and stage 4, as well as all these other combinations. Okay, so that's not possible in any world that I know of right now, except for a situation where we're using automation. Okay? So those are some of the challenges we have, not anything that some of you probably don't face on a regular basis as well. Some of the components of our framework. We are primarily focused on 2 parts of testing. One is functional testing, and that's where a majority of our test cases are at. And we also have a significant number that are in hitting our web services, and we're doing mid-tier testing that's basically request and response validation. Okay, we'll talk a little bit about that. We use, as I mentioned, HTML and a test runner stack. If you're not familiar with that, that starts if you are in the IDE and you launch your test. It kicks you over into a browser. You're actually running the test runner at that point in time. We don't use the IDE for creating of code because it's a little slow compared to what we need to use. But we use the test runner. We launch it from a command prompt. We've made some modifications to the test runner, a couple of important ones. The first one is that we've made it so that the test suite files that you create can accept parameters. So we can have more common scripts, and we just pass them parameters so that they know what test it's executing with, and so forth. And we've also changed the test runner. The other major modification that we did to the test runner is we changed it so when it fails, it doesn't continue running the subsequent test. It actually jumps to the last test. So all of our test suites, we have an initial setup, and at the end we have a cleanup script that also does some other things like finishing the logging process and sending out emails and so forth. And so the test runner has been set up to jump to the end when it fails. So we don't run, because our tests are always dependent on the previous tests, or not always, but most of the time, majority of the time, they're going to be dependent on the previous test being successful, because we're building on, from an application flow, we're building on whatever process was done in the previous test. Okay. Our mid-tier stack, we have 2 different flavors of mid-tier tests, web service tests. One is basically written in Selenium and Java and using JUnit to control that. And that's really a request and response. We've built a xQuery validation engine. If you're familiar with AltoX, I can never pronounce the name of this company, but the company that does XML tools, they actually have a COM component that we're using in our validation engine. And what that allows us to do is we can build interrogation of the XML based on node existence, or what the count of the nodes are, what the values of the nodes are, what the data type of the node is. Because in XML validation, you need to have that level of flexibility. And then we have a second part of our mid-tier test, web service test, built in C# and using MBUnit and Galileo, if you're familiar with some Microsoft stack. And this does essentially sends a request to 2 different systems. One is the current system that's under development, and one is the system that represents our production code, gets results back, and it compares the results to make sure they're the same. Okay? Or to the extent that they can be. Okay, so we have some fundamental concepts that I think are quite important to not just our Selenium implementation, but any automation implementation. Some things that we learned through the QTP deployment that we did. We have strict adherence to code management. Nothing gets executed unless it's coming out of SVN. In fact, when you see our robot configuration, you'll see that it only pulls code from SVN to execute. So this gives us a great deal of control, visibility, accountability to what's going on with code. So all of our scripts are in SVN. We use parameterization wherever possible. And by default, HTML code doesn't necessarily support this easily, but we came up with a fairly workable solution that we put our parameters in an HTML table, we load the table, and we have a single extension that we added to user extensions that reads the entire table into variables. So we can read in, with one command, we can read in parameters. In fact, we do, our parameter file for our UI layer probably has about 5,000 variables in it, and one command reads it in, no problem. So that's very important. We have some standards around logging. So all of our executions, regardless of what part of the framework they're using, whether UI tests or mid-tier tests, they have to follow the same logging requirements so that we know when the suite starts, when the suite ends, each of the test cases that are in the suite, it has to be logged from start and finish. We do additional logging. We do variable logging, so what environment is it running in, what's the versions, what versions are in that, and what version of application code are in that environment. So something that we've put across. We're always looking for simplicity and scalability. I think I've talked about that already a couple of times. Code reuse whenever possible, and so we use a great deal of common scripts in HTML. Doesn't make it real easy to have reusable objects, but we've found ways to do it. We use the include extension, and so we include chunks of code all over the place, and a lot of times you'll see scripts that are nothing more than a series of include commands. Okay? We have abstracted the execution from the development. And what does this mean? It means that the people who are executing the automation scripts are not the people who develop them. And this is important for two reasons, and I got to say both of them because I know our team will be watching this. But the first one is we want the people who are writing scripts, we want them to be focused on writing scripts and not on executing automation. Okay? And if you're working with functional automation, you want to make it as seamless and hands-off as possible, but functional automation needs some care and feeding to say when something fails, why is it failing? But so what we've done is we want our automation engineers to focus on writing automation and not focus on running executions. The second part that's more important, that's just as important to me at least, is that we make sure that there's a certain level of reliability in the automation, so synchronization issues are all worked out in the development process, because the developer knows that they have to turn it over to somebody else, and if that other person is having problems with the execution, they're going to get called back in to fix them on a regular basis and quite publicly. So we have a little bit more accountability in that synchronization. Some things we do around synchronization, we don't allow pauses, we don't allow hard-coded waits unless they're absolutely necessary. And this is just something to keep our flow going. My pet peeve about pauses and hard-coded waits is that it's an easy way for automation engineers to avoid figuring out what the right synchronization point should be. So rather than just hard-coding, rather than figuring out what is the right element to wait for, let's just put a pause in here. If we wait 30 seconds, it'll be there. Well, that's great until you start looking at all these 30-second waits all over the place. Your executions are slowed down. And at the same time, it's not always going to be 30 seconds. It may be longer, and then your script's going to fail. So we don't allow that. And then the last piece that you'll see through this, our infrastructure for automation and our development machines is 100% virtualized. And this is actually quite important because as we expand our execution requirements, it becomes much easier for us to expand the number of robots that we have running automated executions. Today it stands at, I think, 40 or 45, something like that, and we'll probably be upping that number to probably 80 before the end of the year, so that because it's virtualized, it becomes a lot easier for us to make that increase in the number of robots we have. Our development machines are also virtualized, so the developers writing scripts are executing or doing their development work on a replica of what they're actually going to be executed on. They're not allowed to change their development environments from a standpoint of what software is installed on it or how it's configured, because it's configured exactly like the execution machines. Okay? So some of the components, we've already mentioned some of these: SVN, VMware, JUnit, all of those I mentioned, Selenium plus some minor enhancements. Something that's a little interesting that we do, or a little different, maybe a little bit odd, some people might say. We use Jira as our defect tracking. We also use Jira for our metadata about our test suites. Okay, Jira is quite expandable. You can add new issue types. You can add all kinds of custom fields to support what we need to do. And so in this case, we are using Jira to track all of our automated suites. It gives us all the parameters that we need to run with them, what valid parameters are. All that information is kept in Jira. It's been a very good use. Something we debated about writing our own tool to manage that metadata, but we didn't have to invest in writing a UI to manage it. We already have one, and it's one that we're using consistently. Just one more note on Jira before I go on. Somebody asked about dashboards. We also track our executions in Jira, and so we can create dashboards about what's been executed and what hasn't been executed, and it becomes very visible to anyone who's interested in what's going on. Mostly I get questions from our development teams about what new automation is being added for their areas. That's what they're mostly interested in, because they just assume we're going to run it all before the release. But in Jira, we can actually track, obviously we can track all of that. They can see exactly what we're currently working on for this month, what's going to come out next month, what's going to come out the month after that. or what we think might come out the month after that. Okay, we have a couple of custom applications that are fairly important to what we're doing. We started this project before, if you're familiar with Grid, we started Selenium before Grid was really around as a usable project, so we basically have our own version of Selenium Grid that's a little bit more tailored to us. We have a UI for initiating executions and looking at status of what's going on, scheduling and creating packages and so forth. Hopefully we'll get a chance to take a look at that. We have a dispatcher that monitors our execution farm to see which robots are currently active, and it decides when there's a new request from the UI or from other sources. We also have a command line interface to submit requests for execution. The dispatcher will decide what robot to send it to, because some of our robots have different configurations. This one has a different browser on it. This one has a different operating system. Somebody requested the test in this version of the browser, then we send it over there. Okay, that's what the dispatcher does. I mentioned the Xquery validator, and we have various other helpers. So some of these things may not be as obvious that we need these types of things, but with using HTML, we're restricted to what JavaScript can do, because it's basically the test writer is running all in JavaScript. JavaScript can't go outside of the sandbox. It can't read databases. It can't do a bunch of things. And so what we do is we end up writing little helper applications to manage that. We have a simple URL for logging. We just call open it. Our logging consists of an open command with a URL with some parameters on the URL string, and that creates logging for us. So it's one command. It's very easy to do. Very simple. We wrote some of this stuff early in the pilot phases of Selenium, saying, oh, we're just going to do something as simple as possible to get through our pilot project and see what's going on. And two of these helpers are still in use, the logging and the query page that we wrote, that basically took 15 minutes to put together. And it's something that has been running for 3 years now, and we have no reason to change it. We haven't found a reason to change it yet. So we will change that. So, okay. So that's a little bit about our infrastructure. Our infrastructure here is kind of a graphical representation of our framework, how it sits through there with robots. Okay, a little bit about our release process. This is going back to our application release process to the production site. And so essentially what we have is we have a short period where we have development starts and we have code complete deadline, and then between code complete and when we release to production, we have a short period of time where we're doing our final verifications, what we call from our legacy days of doing on-premise software. We actually call this our RC phase because it's a release candidate, but it's a little outdated, that term. But anyway, then we release it to production, and it will stay in production, obviously, until the next release comes out. In between that release, we have scheduled patches that are smaller in nature. Typically, we don't target major features to go into those scheduled patches. Sometimes they do, based on the business need. Okay? And then, unfortunately, between those, we have a few other fixes that go in between there. So when you look at how long this takes, overall, this is a monthly release cycle. So the first phase is 3 weeks of development cycle. And what we do during that 3 weeks, I'll just pull all these out. Some of the different types of automation that we plan to run during those 3-week time periods. And then during the last week, we are running our full inventory, and we're running it at least 4 times now, based on the different states that we're in for the deployment. And then we also have some what we call deployment validation, post-production. So after the release goes into our production environment, we run automation to verify that everything is working in production that we thought should be working. Now it seems a little strange that we want to do that, but there are some variances between our test environments and our production environment, and some variances that we can't change, and that's not ever we can't ever make them exact replicas. And so this is just a step that we can do to make sure that we feel that everything that we shipped that we wanted to go into production actually made it into production. Okay? And we found a few times in that post-production window where we found something that we didn't expect, and it had to do with our caching mechanisms, that is third-party caching, that we weren't updating something properly in the cache. And that's not something we do in our test environment. So we don't use a third-party cache. And then our scheduled patches, we actually have a set group of automation that runs for each verification of each of those patches. Okay? And we're given a 24-hour period on those patches to run that. Okay, so we run as much as we can. Pretty much in 24 hours, we can we could almost run the entire inventory, but we probably don't do that in this case, or we don't do that. It's short of that. It's about 20% of our full inventory. And then with our hotfixes, we usually have a 2-hour window from the time that the code is completed until we send it to our production environment. That's the minimum time that we try to allow, unless it's something more critical, then we ship it faster. Okay. And so we have a small package for that as well, to do verification. A little bit of idea about what our code structure looks like. This is from about 9 months ago, so it's a little bit outdated, but our fisheye is not working currently, so I couldn't get the current statistics. But we do have 13 million lines of code in our automation, which is actually equivalent to what our application that we're testing has. Our application that we're testing has about 16 million lines. You can see majority of this code is HTML. Okay? And so this is actually on trunk. It doesn't count branches and so forth. We actually have a process where we branch at the same time. The development code branches so that we need to execute something against that branch code. We have the copy of the automation as it existed at that point in time to run. Okay. Some additional uses, and then I'll try, hopefully, how much time do I have left here? I think I have about 5 minutes. I can either, I can show a quick demo and to see some of the things that are going on. Some other things we do besides product verification, we do our deployment verifications. We do operation changes. They put it into an isolated environment. We run validation against it. They get statistics on benchmarking for performance and so forth. That's part of what we do with that. Our disaster recovery site goes through changes, and they want to validate and make sure that it's working. We run our automation against that. Other things for benchmarking for different types of changes that they're making. If they're going to make some change to our F5 configurations, they want to validate that it's working. We use automation to do that. A couple of other things that we're using automation for at Concur is that we are doing new client configuration verifications. So we have a suite that is somewhat dynamic. It figures out what the configuration is and figures out how to test it. We run through that test, makes it, basically the goal there is to reduce our implementation time. And then the final one that we're starting to do now is, the requests never stop, which is a good thing. But now we're actually writing scripts for our pre-sales team to populate data. So they want to run a script to create data instead of creating themselves. It's a great idea. So something else we're doing. So here's what I'm going to do, because I don't think I have time to go through the full demo. What I do is, because we have only a few minutes left, I'll stop and take some questions. And then if anyone's interested in seeing more of this, I'll be happy. I'll obviously be here for the next couple of days. Just let me know when we can do a demo. I can do a demo for you and to see a little bit more of what's going on with our infrastructure. So any questions? Yeah, it's a good question. So the question is, why are we using Selenium to run our mid-tier test when we're doing web service calls? And the reason for that is that most of our mid-tier requests require some setup. So it needs the application state needs to be in a certain point. We may need to have users. We may need to have a transaction in a certain state before we can execute this test. And so rather than redoing the test in the mid-tier, we actually reuse the Selenium test to do a setup in those cases. We also, so by building it into the Selenium framework, it basically everything works the same from an execution standpoint, and we can utilize the setup assets that we already have written in Selenium. Okay? No, so what I mean by setup is the application setup. So in order to check to see if a report has been approved, the report has to be submitted. The expense report has to be submitted. So if my mid-tier test is to check to make sure that the submit is working properly, that my call to the submit web endpoint is working, then I need to make sure that there's a report in that state ready to be approved. Okay, so when I talk about setup, it's more functional application setup.
So your web service calls are basically triggered via UI button. You're not making like a...
We actually have a test page to trigger the UI call. So we actually have a test page for each of our UIs that basically points to each of the mid-tier servers, the endpoints that we have, and we'll go and put the request into that, and it will submit the request to the endpoint and get the response back, and then we use Selenium to pull that into the validation engine that we have. So again, it's trying to reuse code that we already have without reinventing it. We could certainly have reinvented that in a different way, and we could have certainly used mid-tier tests. In most cases, we could use mid-tier tests to do setup. Sometimes it's not possible. It can only be done through UI. So, do we have a process to test the scripts? That's an interesting point when I get asked. So do we have automation to test this application? Or do we have to? The answer is no, we don't, because it becomes, okay, if we build tests for this, then how are we going to test those tests that are testing this? And then it just keeps going on and on. And realistically, I'm more focused on, is the automation expanding from a coverage standpoint? Okay? So the question is, do we have any process for documenting? And I think the short answer to that is yes and no. Basically, we have coding standards that everyone's expected to follow from a commenting standpoint. Because code is very visible when you check it in, we have some level of accountability there. Is it the best documentation? No. Is it the worst? No. Somewhere in between. What portion of that code is used? All of it. Because what we do is we prune off the code that we're not using. So we take that off. So all of that code is actually in use. So the question was, do we use the same standards as the development team? Where it exists and where it makes sense, we do use it. I can say that that's a pretty small percentage of what we do. Our coding standards are really more focused on the code that we're writing, and the coding standards are more about, you know, if you're going to do a click, you got to make sure that that element is visible, because our application is quite. Is that it? I'm getting pulled. Yeah. Okay. So. Okay. I'm out of time. Right. Okay. So I guess in closing, my take on the Selenium project has been that it's a huge success, and I measure that by the number of people outside of my office asking for more. Okay? So as long as you have customers who are asking for more, meaning our development teams, our implementation teams, our other teams in the organization, when they come to us and asking for more, we must be doing something right. And so I measure our success based on how well that's going. I also measure our success on how many defects we're identifying with automation and how many defects we're not identifying. Now, the defects we don't identify are not necessarily a result of automation unless we have a specific test case for those defects, and then we have to look at that. But our test coverage is function point based, because there is no code coverage tool in the world that will tell us what coverage we have on our application stack. And I'm not really a huge fan of that. So we use function point analysis to say what points do we have covered with, and that's almost it's a very manual process that we keep track of. We also have the ability to look at the endpoints that are being called, because all of that transactions are being logged, so we can do some validation of what endpoints we're calling with the UI automation. So, okay.